Hi everybody, I'm Hugo, and today I will talk about turn and dialog level metrics, and also annotation with Amazon Mechanical Turk. So the presentation, I will first start talking about the metrics. So there are three. First are the turn level metrics. We have three turn-level metrics, which are validity, comprehensibility, and confusion. Validity is whether or not the turn makes sense given the context. Comprehensibility is whether or not the turn gives sense without any context. And confusion is whether or not the turn creates confusion for the next speaker. We also have dialogue level metrics, which are engagement, fluidity, and breakdown. Engagement is whether or not the participants are invested in the conversation and how are they invested in the conversation. Fluidity is whether or not there are any awkward moments within the conversation. And breakdown is whether or not the conversation are losing, one of the participants is losing the other participant, and whether or not they try to recover and achieve recovery of the conversation. So for I will go through the annotation process. So first is let's talk a bit about the Amazon Mechanical Turk. You probably know about it, but how does it work? Basically, we submit a task as an HTML form, and we do that either on the web interface or through their API. We chose to do it. So we chose to do it through the API. And why did we do that? It's because basically making a script and capable of pushing different tasks would make people create less mistakes. When you use the web interface, you have to fill up every information now and then, and it's probably going to create a lot of mistake, whereas the API is going to be easier for everyone to use. Our first experiment was on the validity task, and we used the topical chat and the empathy corpora. We took 450 turns from each corpus and rounded them down to conversation length. What we wanted to do was also having around 5 annotators for each turn. Why 5 and not lower? Because since it was the first trial, we wanted to know how reliable were those annotators. So our first results. For that, for the first results, we used Krippendorff's alpha as the basis of the quality of our results. We could have went for kappas, but the fact that we used Amazon Mechanical Turk make that we had Turkers who did not annotate all of the turns, which mean that there would be missing values, and that didn't work. So our goal with Krippendorff's data is alpha is to have a value between 0 and 1 and around 0.5 to 0.6, because that would be achievable agreement. For that, we also chose to try to measure the annotator quality. For that, we measured the deviation from the majority vote. And basically, what you can see here are two histograms representing the data that we different parts of the data. So first, we have the full annotated data and how much each annotator deviates from the majority vote. We can't exactly separate the bad annotators from the good. I mean, obviously you can separate the one who has 100% frequency of error, but what we try to do is have a better criterion. For that, we have used we have added to the empathy and topical chat data, we have added fake data, which was generated by sampling turns and adding them instead of the right turn, which made the valid and the dialogue invalid. And on this, we expected everyone to generate to answer invalid. And what happened? What happens is that we can see that there are some bad annotators because those don't. Those have almost 100% error rate. So we have removed these bad annotators, which give us a better alpha, and this alpha is around 0.5 or 0.6, which was really good. What we would like to do in future works is experiment with different scales and annotate all the other metrics and also annotate other data sets, because right now we are only working on human data sets, and that would give us the possibility to compile a new data set. All right. I do think, okay, that was the end. Oh, wait, done. Okay, I've had issues because slides have disappeared and reappeared. So yeah, so here we have the slide where we have the annotations that we have discarded. So what you can see, what's interesting is looking at the right this graph with which shows how many times the turns are annotated, and when we move the threshold of errors, we see that we have a better alpha. So here we can see it with the purple line. And what we see is also we diminish the number of turns annotated until a point where we actually lose. So what we want is probably having a threshold around 0.5 or 0.6, where everything is still fully annotated, and we have a good alpha.